Hey folks, Troy with Oh, that's heavy. That trashy 3D CGI logo almost killed me. I almost died. In this video, I'm going to show you how I made these threaded wood containers and how I inlaid aluminum and carbon fiber as threads. I'll also be showing you how I did this in the CAD software, which is computer-aided design, and also do some CAM work, which is computer-aided manufacturing, and then we will go out to the shop and do some machining. So I've been prototyping different threads off and on for several months now. I've tried all different types of threads, from think quarter 20, UN threads, or metric M5, M6, that kind of thing, which are typically like pointed threads. I didn't really like those for wood. I wanted something that looked a little bit chunkier, maybe even dummy thick. I think I found what is the best style for wood jars like this, and it's based off of bottleneck finishes or bottleneck threads. And if you Google bottleneck finish, you'll see all kinds of resources. The wood jars that I sell on my website and my Etsy shop are probably closer to the lug style, since I use a multi-start thread. Maybe it might be some sort of hybrid, I'm not sure, but it's loosely based off of bottleneck threads. One of the most important measurements or dimensions is this S dimension right here, which is how much space there is between the top of the container and the thread start. So that will prevent it from falling off or cross threading. And we'll touch on that in the CAD side in a little bit. So I've tried a variety of Threadmills. My Threadmill collection is maybe out of hand, but I've tried single form threads, multi-form Threadmills, Acme Threadmills. I finally landed on these right here, which are key seat cutters or keyway cutters, and you can even find them under T-slot cutters. And these technically aren't even Threadmills, but they work great for this. Let's hop into CAD and I'll show you how I model these threads, and then we'll do some CAM stuff. In the CAD software, I use what is called the coil command to create threads. And I'm going to place the coil on this construction plane I created and just slap it out there. Now for the type, I select revolution and pitch. The diameter, you don't even need to know it. You can just click on these three dots and select measure, and then I'll click on either this edge or this face will work. I'll come back to pitch in a second. So for the section, it's going to be square. It's going to be the outside of the cylinder face. And the section size is the size of the actual thread that you want. So mine, on something this size, this is the 3-inch that I'm working on right now. It's going to be 1.5 millimeters. I want a new body. And the pitch is double the section size, assuming you have the type set to revolution and pitch right here. So I'll set this to 3, and that looks way better. Let me hit OK. And you can check that it's correct by measuring from the bottom of one thread to the top of another. That's 1.5. So, which essentially means you can have another thread slide in between here, because this one is 1.5 millimeters, because that's what we did for the section size. So this is for a single start thread. Now, if you want multi-start threads, you need to change a few things on here. Your section size would stay the same. Your pitch sort of stays the same. So the pitch is actually going to be multiplied by the number of threads that you want. So if I want 2 threads, my pitch will now be 6 millimeters. So it's going to be the section size times 2, which would be for 1 thread, which gives you 3. And then you multiply that by the number of threads you want. So let's do 2 threads. So we'll make this 6 millimeters. You can see it looks much steeper now. One thing I forgot to do. you want to change the revolutions as well, which would generally be about half. So if you want 2 threads, you would do like 0.5. So that'll make sense in a second. Let's go take a look. So here's half a thread. So now I'll do a circular pattern. I'm going to select that thread around that axis, and I'm going to select 2 here. And now you'll see there are 2 threads, and the pitch is correct because, again, you can inspect and measure from there to there, 1.5 millimeters. So let's do something that has even more. We'll do 4. So section size 1.5 to get the pitch, multiply it times 2, which would be 3, times however many threads you want. So 3 times 4. So this is going to be 12 is going to be my pitch. Oh, I'm going to definitely want to change the revolutions to, we'll do 0.25. Hit OK. And now I need to update the circular pattern to 4. And now we've got a 4 start thread. I think that's cool. As I mentioned before on the thread specification thing, this is the parameter that was important from the top of that thread to the top of the container. So I leave about 3 millimeters on here, which makes it really easy when you're threading it on. So you don't cross thread it, you don't put it on, it won't fall off easily. Took me a while to figure that out. But you also have to leave space under here as well, because you're gonna have more space on the top to thread down. It's confusing. It hurts my brain. Brain hurty. So for the thread inlays, it's basically the same thing, except on the coil command, after this step, I do a offset. I actually did a fillet here. Let me hide this body. Let me hide the body under the house. Just kidding. So I offset this face into the cylinder body here, and then I combine cut them. What that looks like is there's a groove cut on the inside of the cylinder, which will act as the kind of seat for the threads that I make separately and then inlay in there. So in the cam side, I use the key seat cutter and a trace toolpath. I select this edge right here, and then I select sideways compensation to be left. Otherwise, the trace toolpath will plunge straight down and ride on the center of the bit and ruin your piece. Ask me how I know. And then I did a pattern, a circular pattern. So it's just going to go all the way around and machine that out. Let's see how that looks with the machine modeled. This took me ages to figure out how to model my machine and get the kinematics correct. Oh my God, it's not fun. But it's really cool. All right, let's go take a piece of wood and throw it on the machine and do this. So I made these out of this Claro walnut. It's a pretty nice piece. It had some nice flame or curl. So this project started with a custom Etsy order for some wood rings, and the customer didn't want any of the sapwood, the lighter wood you see there. I actually sent him a picture of this piece of wood, and he is using them for these headphone cans. The first thing I do is kind of break this piece down to save as much material as I can. And with it cut roughly to size, I stick it down to the CNC machine. I use what a lot of people refer to as the super glue trick. Basically, you put a piece of blue tape down or painter's tape down on the thing that you want to stick something to. You stick a piece of blue tape to the other part, and you put super glue in between them. And it's an incredibly strong bond. First operation is an 8mm roughing end mill, and you can hog out a lot of material quickly. So this roughing end mill has a 20mm flute length, so I had to do this in multiple operations or multiple tool changes because it's just not big enough. So I threw on a longer roughing end mill to continue machining. With the customer's order finished, I could get it off the table and continue with the threaded containers. This is an 8mm 3-flute finishing bit, so it's going to clean up all of the kind of grooves and nastiness that the roughing end mill left behind. And finally moving on to the actual threading portion, I guess, even though it's not a thread mill and it's not a thread toolpath, it's still threading, I guess. I could watch this all day, and sometimes I do. I'm adding chamfers here because chamfers are cool. In case you don't believe me that the super glue blue tape trick doesn't hold very well, here you go. So here's a 1.5mm thick piece of aluminum for the threads. I'm using a 3-flute aluminum end mill, and you can't see it here, but I'm actually using a mist coolant, which is 99% isopropyl alcohol. I didn't know you could use alcohol as a coolant, but it works amazingly well. You can kind of see it right here. And here's some more of the same, cutting out the threads in the carbon fiber, except there's no mist coolant. Look at that. Look how nice those look. Look at those little threads. Look at them. Look. All right, so this is an 8mm roughing end mill for the tops, or for the lids of the containers. After the roughing operation, I moved to a 3mm end mill to clean up the faces. So here is the key seat cutter on the lid. That's neat. That's neato. So this is where I keep my sanding devices. Oh, there it is. I've been looking everywhere for this. So here I'm actually sanding in between each thread with this little bent piece of aluminum that I made with some sandpaper that I stuck to it. It works really well for getting in there. I do some hand scraping to get rid of the machining marks. This is a jig or fixture I made for the router table to make coasters, and it worked out pretty well for this as well. This has bearings on either side that are adjustable. So to do the engraving of my logo on the bottom, I had to machine a pocket to flip the part and hold it in place so I knew where to locate it. This is a 1mm diameter 2-flute end mill. I was messing around with the lights here to see if I could get it kind of more visible, but I don't know, it was kind of difficult. After the 1mm bit, I switched to a 30-degree engraving bit, or a 30-degree V bit. I tend to do a different logo pretty often. I like messing around with different designs, and I actually really like the way this one turned out. The fonts, 2 different fonts together. This is a flap disc on my drill press. All right, let's put some threads in. I'm using some medium super glue here. After I put this in, I actually flooded it again with some thin super glue to get it in all the negative space. Finally, finishing. So I'm using a hard wax oil here. I pretty much use this on all of my projects. This stuff is incredible. It's super forgiving, super easy to apply. You can't over apply it. Put as much as you want on, wait a little bit, wipe it off, and you're done. That's nice. So that's pretty much it. It's after this, I will take a bunch of pictures, and then I'll hopefully show them in this video. Like right now, you should be seeing some pictures. You guys should probably like and subscribe. Thanks for watching.
Push the like button and subscribe, which is Italian for threads, I think.